Okay, so here are the volume of spheres, cones, and pyramids. So for the first example, and you'll notice with all of these that are triangular shaped, you'll notice that we'll be dividing them by 3 almost entirely. So you'll notice that common theme throughout each question. So for a cone, here I have the diameter, which is 19, and the height of this cone, which is 40 millimeters. So the formula volume equals 1/3 pi r squared times h. First of all, we need r, which is the radius. And keep in mind that radius is half the diameter. So for the radius, we're going to divide 19 by 2, which is 9.5. And that will be the amount we use for our radius. So when we're plugging these values in, we get 1/3 times pi times the radius squared, which is 9.5 squared, times the height, which is 40 millimeters. Always check to make sure that your units are all the same measurements. For instance, I could have made this height equal to 4 centimeters. Then we would have had to convert everything to millimeters, and we know, of course, that there are 10 millimeters per centimeter. So these two values, 40 millimeters and 4 centimeters, are the same, but we need them all in the same units. So please make sure to have them all in the same units. So we'll use all millimeters. Then it's just a matter of going through my calculator, doing order of operations. So I do 9.5 squared first, then multiply by 40, then multiply by pi. The multiplication you can kind of do in any order. And then multiplying by 1/3 is the same as dividing by 3. We could multiply by 1/3 or just simply divide by 3. And I get 3780.38. It's a good idea when you're not being asked to round to a specific decimal place. Usually round to 2 decimal places if you can. So I get that answer, millimeters squared, because we're dealing with, cubed, because we're dealing with volume. So 3,780.38 millimeters cubed, and cubed shows that we're dealing with volume. Next example is a pyramid. So for the pyramid, you'll notice that, again, it's 1/3, or dividing by 3. It's a triangular shape. So when I'm going through this one, if it's a square-based pyramid or rectangular-based pyramid, that's the shape of the base. This is a rectangular-based pyramid. And you'll notice that because the length and the width of the base are different. One's the length is 15, the width is 13. So when we're plugging through these values, the area of the base is 15 times 13, and the height is 39. Again, everything's in centimeters, so that's good. If something wasn't in centimeters, then we would have to convert it to centimeters first so that everything is in the same units. So again, I just multiply this through, no pi to deal with in this case because there's no circle, no circular base. So I get 15 times 13, that's the area of the base, divided by 3, or times 1/3, and then times the height, which is 39. So I get an answer of 2535. 2,535. And again, this is cubic units because we're dealing with volume. So there's the volume of a pyramid. And they'll always give you the height. It might be outside, or they might give you the height on the inside, showing a little 3-dimension, or like a right angle to show that the height is going straight from the tip right down to the middle of the base. So either the height will be on the outside, or it could be on the inside like that. Last example here is a sphere. And a sphere, again, is divided by 3. We have a circular type of shape. And the volume of a sphere is 4/3 pi r cubed, as shown on your formula sheets. And again, I'm given the diameter, so I have to find the radius first, which is just half. So that's going to be 15 feet for the radius. Then it's just a matter of plugging in my values into my formula. So 4/3 times pi. And this one's only based on the radius or diameter, so it's a little bit simpler. And that's going to be 15 cubed this time. So that's the first thing I'm going to do, is my 15 cubed. Then I can multiply that by pi. And then I have to multiply by 4/3. So when you're doing it in a calculator, it's a good idea to use brackets around the fraction. 4/3. And then my final answer is 14,137.17. Again, we'll round to 2 decimal places when we can. So 14,137.17. 0.3 or 0.17. And that's going to be in feet cubed. Below, I have another extension for this one, for capacity. In the question above, if the sphere was filled with water, where 1 foot cubed is equal to 7.48 US gallons, how much water could it hold? So if this sphere was, say, like a water tower or something, then we're trying to figure out how much water it could hold. So the question states that 1 foot, for every 1 foot cubed, for every 1 cubic foot, it's 7.48. Well, I have 14,137.17 cubic feet. And we have to multiply that by the 7.48 because for every 1 cubic foot, it's 7.48 gallons. So it's just a matter of multiplying the capacity out. I multiply that by 7.48, and I'm left with 105,700 and I think it was 46.01, and that would be gallons, US gallons. So for capacity, usually what they'll do is they give you some rate of capacity, and you usually have to multiply your volume by that capacity to figure out what it would be equal to. Hopefully that helps, and if you need to, rewatch the video.